But the answer will surprise you. Sabertooth power wasn't in the bite.
Sabertooth power wasn't in the bite.
For millennia, the saber-toothed cat dominated megafauna landscapes. Its signature weapon was those enormous, curved upper canines. But these fangs could grow over 11 inches long in some species. We assume this meant an incredibly powerful crushing bite force. But modern biomechanics tells a vastly different, crucial story. Now that we understand the iconic weapon, let's explore its structural weakness. Cons: the entire evolutionary design prioritized gape opening over muscle mass. The bones supporting the fangs were relatively slender and lightly built. But this architecture meant the saber-toothed cat had a surprisingly weak closing force. Compared to a modern lion, its bite pressure was significantly reduced. A muscle mass dedicated to crushing was minimized to allow for extreme opening. This wide gape was necessary to clear the massive weaponry before striking. The goal was never to clamp down and crush bone, like a hyena. Instead, the bite served as a highly specialized, fatal stabbing implement. The strategy relied on positioning the prey, not brute jaw power. They aimed for soft tissues, severing major arteries or the trachea. But this attack required the prey to be completely immobilized first. The ambush, the takedown, and the securing were the primary challenges. The jaw strength was only needed for a quick, disabling stab, not sustained pressure. This specialization is an extreme example of evolutionary trade-offs. Build power for crushing, and you limit fang length and flexibility. A modern cat's balance crushing ability with piercing puncture power. The saber-tooth essentially traded all-around utility for lethal singularity. If the fangs hit bone during the initial strike, fracture risk was high. The supporting tissues required protection from accidental impact. This strategy was effective because of the prey available during that era. Many megaherbivores had thick hides but vulnerable internal structures. The hunt demanded perfect stealth and an absolute element of surprise. A failed ambush meant high risk of injury or simply failing to eat. The leap, the grapple, the precise angle for the killing puncture. The jaw opens, maximizing the reach of those specialized cutting implements. The fangs deliver a deep, efficient wound designed for rapid systemic shock. It was an evolutionary commitment to precision over raw, gripping strength. The evolution often favors the specialized tool that perfectly fits a specific niche. The temporomandibular joint, the hinge, could not support sustained crushing loads. This limited the ability to bite down with the force seen in bears or crocodiles. This specialization made the saber-tooth vulnerable to changing environments. If the large prey vanished, the saber-tooth lacked the generalist tools to adapt. A misplaced strike against resistant bone could result in catastrophic failure. Paleontologists reconstruct this history using fossilized evidence and modeling. Computational physics allows us to test these ancient mechanics virtually. We see this pattern across different saber-tooth lineages over time. The necessary jaw articulation demanded a unique musculature arrangement. The neck structure also had to be robust to withstand the impact forces. Every movement was calculated to protect the extremely specialized killing apparatus. Thick, specialized gum tissue provided a vital shock absorption layer. The entire body plan reflects this specialization: powerful forelimbs, weaker bite. An energy that could have reinforced the jaw was redirected to limb power. This forelimb strength was necessary to maintain the necessary tackle position. The spine needed flexibility to accommodate the extreme reach of the head strike. The fangs were designed to pierce, not to crush and hold. The high pressure yields bone destruction, low pressure allows deep penetration. Once the primary vessels were compromised, the battle was effectively over. And the saber-tooth cat was a master of lethality, not brute force wrestling. This evolutionary path maximized efficiency for its specific prey set. We often project our modern understanding onto extinct titans of the past. But every predator's success is dictated by its unique structural compromises. But the saber-tooth's weakness in the jaw was the price of its iconic, piercing glory. Understanding the mechanics reveals a more elegant and surprisingly fragile hunter.